Hi, Algebra 2. So we are moving on to our final unit for the year. We're going to check out statistics. So you'll be able to find all the PDFs that you need on Google Classroom. They should have been uploaded at 8 a.m. today. The one that you want to follow along with is called Student Notes. Okay, so if you want to print that out, feel free. Otherwise, let's jump right into it. So we're going to start off with just some fundamental counting principles, which is just a way for us to calculate the number of different possibilities when we're dealing with a chance scenario. So first off, we're going to look at this. If decision M, so one decision can be made M ways, and decision N can be made N ways, then the two decisions together can be made in M times N ways. Okay, so if we have two separate decisions or more, all we have to do is multiply the number of possibilities together. Okay, so let's check out a few examples. This one, we have the ice cream shop offers a choice of three cone sizes, 15 flavors, and 8 toppings. How many cones are possible if you can only choose one flavor and one topping? So we have 3 choices for the cones, we have 15 choices for the flavors, and we have 8 choices for the toppings. So 3 times 15 times 8, if you do that in your calculator, that gives you 360. So there's 360 different options that we could have for that ice cream. Okay, for number 2, it says Virginia license plates consist of 3 letters followed by 4 digits. How many different license plates are possible? So let's think about this. Letters, we have 26 different options, right? Because there's 26 letters in the alphabet, and we're doing 3 letters. So 26 times 26 times 26. Okay? And then we're also doing 4 digits. So remember, digits are the numbers 0 up to 9. So there's 10 different options. So I'm going to do 4 tens. And when I multiply all that together in my calculator, I get 175,760,000. Get a big old number. So that's how many options there are for license plates in Virginia. Okay. So next up, we have Nick's science test has a section with 12 true or false questions. How many different ways can Nick answer these questions? So all I have to do here is remember, when it's true or false, there's only 2 options, either true or false. So we have 2, and we're going to have to multiply that to 12 different times, right? 2 times 2 times 2 times 2, but we have a shortcut when that occurs. I'm just going to do 2 to the 12th power. Remember, that just means 2 times 2 times 2 and so on until we hit 12. When I do that in my calculator, I get 4,096. It says 4,096 different ways to answer. And then for number 4 here, it says to enter their home, the Clayton family enters a 4-digit code. How many codes are possible? So we have 10 different options for each digit, and we're going to do 10 times 10 times 10 times 10. Because they're all the same, we can just write that as 10 to the 4th. And that's going to be 10,000 different options. Okay, so something that's going to pop up a lot in our unit of statistics is factorials. So factorials are written like this right here with an exclamation point. You're going to see a number and then an exclamation point. Right now we're just using n to represent that number. Okay. And all this a factorial is, it's the product of all natural numbers from n to 1. So for example, if we were trying to find 9 factorial, that's just telling us to do 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? And when you do that, you end up getting 362,800. Okay, so 12 factorial, we do the same thing, but we'd start at 12. Okay, and we have something like 479,001,600. 8 factorial, same thing, but go from 8 down to 1. And you get 40,320. Okay. We can even do factorials over each other. So 17 factorial over 11 factorial, what's going to happen is up top we're going from 17 all the way down to 1, and up the bottom we're going from 11 down to 1. So 11, 10, 9, all those guys are going to cancel, right? Because they'll have one on top, one on bottom. So essentially this guy's just going to be 17 times 16 times 15 times 14 times 13 times 12, and then that's it. That gives us something like 8,910,720. Right? So another thing to keep note of is that the 0 factorial is actually just going to be equivalent to 1. So anytime you see the 0 factorial, you're just going to say that is equal to 1. Right? So what we're going to go ahead and do here is check out our calculator. So I know some of you guys don't have this, some of you do. You can always find these on the internet as well. If you just type in calculator to Google, you'll find a pretty solid one that they have. But if you do want to have a graphing calculator and you want to do a factorial, for example, 9 factorial, you just do 9 and then you go math, go over to probability, and you'll see this guy right here, the little exclamation point. And when you put it down just like we got up there, you'll get 362,880. And we could even do that with these more complex guys, like that 17 factorial divided by 11 factorial. And you'll see we get that same exact answer we expected. Okay, so here's where factorials come into play when we're actually calculating statistics. The first thing are permutations. Okay? And this is an arrangement or a lineup in which order matters. So order is important in these scenarios. Okay? So we have a little formula for this permutation. The way we write it is N, P, R, just like that. Okay? So N is the total number of objects available, and R is the number of objects to use for the arrangement. So what we're going to do for our formula here is N factorial over N minus R factorial. Okay? So an important shortcut to know here is that if you have N, a permutation with a total number of N objects, and you're actually arranging N objects as well, that's just going to end up being N factorial right there. So that'll be pretty easy if you're trying to arrange the same number of objects that you have. So let's check out some permutations here where order matters. Okay, how many ways can you arrange the letters in the word dinosaur? So we have 1, 2, 3, 4, 5, 6, 7, 8 different letters, right? So the way we would write this guy, we have 8 total different letters, and we're rearranging all 8 of them, right? So we would have a permutation with 8 on either side. Okay? And remember, we just said that if those two numbers are the same, it's actually just equivalent to 8 factorial. So if we use our calculator, find 8 factorial, there's going to be 40,320 different options for the way we could arrange the word dinosaur. And here we have 7 students are competing in a geography bee. How many ways can they finish in first, second, and third place? Okay, so we have 7 total students, right? And we're choosing 3 places, right? So our formula tells us that we're going to do 7 factorial over 7 minus 3 factorial. Okay, and I'm going to write this one out. 7 times 6 times 5 times 4 times 3 times 2 times 1, right? Down below, 7 minus 3 is 4, so that's going to be 4 times 3 times 2 times 1. And you see how the 4, 3, 2, and 1 cancel? So all we have to do are 7 times 6 times 5, and we get 210 different ways that the students could finish in first, second, and third place. Okay. So let's try a couple more here. We have number 7, Melanie is taking 4 classes this semester. American History, Algebra 2, AP English, and Chemistry. How many ways can these 4 classes be arranged on her schedule? So with this guy, right, we got to think we have 4 different possible classes, and we're arranging all 4 of them, right? So 4 permutation 4, and remember our little trick tells us that that's actually just going to end up being 4 factorial. Sorry if I was a little off there in terms of the video. So let's go ahead and do 4 times 3 times 2 times 1. That gives us 24 different ways she could arrange her classes. Next up, there are 16 players on the baseball team. How many ways can the coach make a 9-player batting order? So 16 is our total number. We have 9 players that we're arranging. So we're going to have 16 factorial over 16 minus 9 factorial. Right? And when we do that, you should get something like 4,151,347,200. And then our last one says there are 28 students in Mr. Miller's homeroom. How many ways can the students elect a student council president and alternate? So we have 28 different students, right? But we're arranging 2 of them, right? So that's going to be 28 factorial over 28 minus 2 factorial. And that's going to just give us something like 756. Right? It's essentially just 28 times 27, because down below we'll have 26 factorial, right? So sometimes we're going to have permutations that have repetition in them. So with how many, let's check out 2 examples where that's the case. How many different 10-letter arrangements are possible using the letters in the word automobile? Right? So in a situation like this, right, we have 2 O's, right? We have an O and another O. So that means that they're going to kind of mess with how many options we have. And all you have to do in this scenario, okay, is you go ahead and you do 10 factorial. That's just to take into account all the different options. But then we have to take away the fact that those 2 guys can repeat, right? So what you have to do is you're just going to do however many there are. There's 2 O's, and I'm going to do the factorial there. So I'm going to do 10 factorial over 2 factorial. That gives me 1,814,400 when I put it in my calculator. Here I have how many different 9-letter arrangements are possible using the letters in the word disappear. So it's 9 letters, so it's going to be 9 factorial over, and check it out, I got an A and an A, and I also have 2 P's, so that's going to be another 2 factorial. So I have something like this to calculate my overall. So when I do that, I get something like 90,720. Okay, so we're going to leave it at that for today, and then our next lesson we'll move on to combinations here. Okay, so please go ahead and let's have you guys for now, let's go ahead and just do numbers 1 through 6. Okay? I might make some changes there, but let's just try 1 through 6 for now on the homework. Hope you guys have a good day.